Okay, I did not want to be rushed on that last video, so I went ahead and made another one. So we're now in video PS26DBlake, and we just finished the concept map number 43 from page 577. We're in week 2-6. Okay. All right, number 44 is an interesting question. You might think this is kind of hard, but once you see what they're doing. It says, elements from one group of the periodic table generally combine with elements from another group and polyatomic ions in the same ratio. Let me give you an example. They are saying calcium forms CaCl2 and calcium forms F2. So they're saying fluorine and chlorine are in the same family, and they're both reacting with calcium. Calcium gives 2, fluorine takes 1, chlorine takes 1. So if it makes CaF2, it'll make CaCl2 and CaBr2 and CaI2. Water, for example, is what hydrogen's up here, oxygen's over here, makes H2O. What will you get when you react with S? H2S. What about silicon? H2Si on down the table. So these are going to form reactions the same way, pair up with something else the same way. Same here, same here. So what you have to do between AlF6 and TeF6, one of them is like SF6. Well, all you got to do this is say is Al or Te. Which one's in this column? Al's over here, so it's got to be Te's in this column. It's going to make the same thing. That's it. So SF6 is similar to TeF6. The next one, we have potassium sulfate and sodium sulfate or barium sulfate. Okay, potassium is here. Now, which one is in the same column? Sodium's right above it. Sodium sulfate's in the same column. Barium sulfate would be different because barium's in the next column. That's an easy question, really. K2SO4 is similar to NaSO4, Na2SO4. Okay, carbon dioxide and carbon CCl2 or CS2. Okay, we've got carbon all the way around, but is it CCl2 or CS2? Which one is in the same column? There's oxygen, S. So CO2 and CS2 have to be very similar. On the other one, we have calcium carbonate and OCO3 or BaCO3. Calcium's here, which is the one that's in the same column as calcium, barium. So those are going to be similar. 45. Anhydrous magnesium chloride is used to make wood fireproof. Draw a dot diagram of magnesium chloride. Okay, all that happens is magnesium had 2 dots, chlorine had 7 dots, and it gave one of the dots here and one of the dots there. I'm going to improve this drawing a little bit. If I make let's see if I can pull this off. I probably can't. Ooh, if I make that blue, for example, think of a brighter blue. Okay, then I can put one of my dots, let's say that one, and that one. I can make those dots blue to show that one of them came from magnesium and one of these came from magnesium. Okay. Artificial diamonds are made using thallium carbonate. If thallium has an oxidation number of +1+, what's the formula for the compound? Okay. So thallium is 1 plus. Carbonate is CO3 2 minus. So that took 2 electrons. This gave 1 electron. Not a match. I have to have another thallium. So it's got to be TH2 CO3. Baking soda, sodium hydrogen carbonate. Oh, you say, oh, I thought you said these all have 2 names. And then it says 3. Yeah. Sodium hydrogen carbonate also has another name called bicarbonate. So you have sodium bicarbonate. And vinegar, which contains hydrogen acetate, can be used as household cleaners. Write the chemical formulas for these 2 compounds. Sodium bicarbonate is made from a sodium ion that has a +1 charge and a bicarbonate ion that has a -1. And I wrote it as bicarbonate instead of sodium hydrogen carbonate. 1 of each, NaHCO3 is your answer. Hydrogen acid they have it called hydrogen acetate, and we have, this is normally called acetic acid. This is the old baking soda and vinegar experiment or a demonstration if you've ever seen it. You know, the baking soda and vinegar volcano. You put them together, acetate ion is C2H3O2 minus, took 1. Hydrogen gives 1 because it's clear up at the top of the left. 1 of each C2H3O2. We'll talk more about this one several times in different chapters. Okay, which number was that? 47. Okay, 48. The linear molecule beryllium dichloride has polar bonds because Cl attracts electrons more strongly than beryllium. Why is the molecule polar or nonpolar? Well, let's take a look. We'll be asking questions like this all the way through chemistry and all the way into organic chemistry. The reason why, and you wouldn't know this, my chemistry students ought to, coming up soon, my organics chemistry students certainly ought to, is that this bond is polar and this bond is polar, but they're directly opposite from one another, and those dipoles cancel. So above, each bond is polar, but their opposite directions cancel, and the molecule as a whole ends up nonpolar. Now let me give you a different example, one you're familiar with. H2O. Water is polar, and it's got 2 polar bonds, but these don't cancel. They kind of work together. So water has polar bonds also, but they are not opposed and don't cancel, so as a whole, water molecules are polar. Number 49. Explain what electric forces between oppositely charged electrons and protons have to do with chemical bonds. Well, if they're opposite charges, they're going to attract, and that kind of a bond is called an ionic bond because opposite electrical charges. I don't have that written down. So get to scribbling. Oppositely positive and negative charges are going to attract. 50, write the chemical names for Fe2S3. Got 2 names. Fe2S3. Iron sulfide, except that's not quite right. We'll come back to that. Why? Because iron is in this part of the periodic table. So we have to say what the charge is. And if the sulfur took 2, and there's 3 of them, then there has to be 6 negatives. And if the 6 negatives are balanced by 6 positives, and the 6 positives are split among 2 ions, how many are they each? 3 and 3. So it's 3 positive, iron 3 sulfide. Next one, CuClO3. Might say copper chlorate. Except for that's not right. Why? Well, similar reasoning again. Copper belongs in here. So we have to know or figure out what the oxidation number is. Because there can be different ones. Somebody asked me with this iron one, why is that? You're letting that rust over there on that bottle thing? Because the ions that make that rust color is iron 3, and one day I'm going to add some sulfuric acid to it and turn that different color because the iron 2 ion is different. So I'm saving that for that demonstration. Well, the chlorate ion is 1 negative. And there's 1 of them. So what's the charge on that copper ion? +1. So it's copper 1 chlorate. Usually your copper ion is 2, but it's 1 this time. Next one, Ca3PO4. Well, that's phosphate, and this is calcium, so it's just calcium phosphate, like so. And you say, well, now I'm confused, because why is there not a number that goes there? Because you need a number when you don't know what the number is going to be because you're dealing with a metal in there. We know calcium belongs here, so we know it's 2 positive, so we don't need a number there, and we don't want a number there. Next one, NH4SO4, ammonium sulfate. Draw an electron dot for BaCl2. Explain how your diagram shows all the atoms are stable. Okay? Barium is in the alkaline earth metals, gives 2 valence electrons away. Chlorine takes 1 valence electron. It's right here. You'll have a periodic table. Takes 1, gives 2. Not a match. I need another chlorine. And when you do that, and they give and take, barium gives 1 electron to chlorine, which already had 7, and now it's got an extra one, and now it's got a -1 charge. And an electron to the other chlorine that does the same thing. And this is what you end up with. 52. What is the oxidation number of iron in the compound Fe2S3? Okay, well, sulfur's taking 2. What's iron doing? If it's Fe2S3, so you got a -2, and a -2, and a -2. Because they're -2 apiece. And I have 2 iron. What's this one and what's that one if this is -6 total? 3 and 3 gives you 6 pluses. It's doable. It's doable. We just did one like that. It says C problem 50 is 3 plus. It's right there. Already did it. Okay, and the last one, the mass of an ammonium sulfate is 132.14 for everything. So you're dividing by that. A nitrogen's 14.007. There's 2 nitrogen because it's NH42. It's ammonium sulfate. Okay, so this is NH42SO4. How many oxygen do I have? 4. How many sulfur do I have? 1. How many hydrogen do I have? 2 times 4 is 8. How many nitrogen do I have? 2 times 1 is 2. That's why I have a 2. So double that, it's 28.014 divided by 132.14 is 0.212 multiplied by 100 is 21.2%. So you should be ready for the test, which is currently scheduled, well, at the time I wrote this, Monday morning. It was scheduled for, I think Friday for green, or Friday for gold, Monday for green. I'll let you know if that changes.